Hello guys, welcome to another new live stream. First of all, sorry for the delay because all of a sudden out of nowhere I started to give the contest and misdone all kill badly. So yeah, we'll not waste time. We are already late. We'll directly go into the solving the questions. The first one, cake making. Oh, just give me a second, guys. Okay. Hello guys, welcome once again. Yeah, here is our first question. Cake making. There are exactly 100 colors in the world, numbered 1 to 100. Chef is making a two-layered cake, and all that is left is deciding colors for the two layers. Chef has decided that we can choose any of the colors 1, 2 up to A for the first layer, and any of the colors 1, 2, 3, 4, 5, 6 up to B for the second layer. However, there is an extra constraint. To encourage diversity, first and second layer should not be same. How many different cakes are possible from the above rules? Two cakes are said to be different either when either the first layer or the second layer has a different color. So one of the colors should be different. Input format, first and only line of input consists two integers a and b. Output format, total number of possible cakes. So yeah, we'll see the constraints. It's already said 1 and 100. In between 1 and 100 are both a and b. So sample they have given, if we take 2 comma 3, the output they have given is sample output is what? 4. So how it is? If we add, the first number represent the color of layer and second represent color of layer 2. So 2 is the maximum. So the first layer can be 1 or 2. So when the first layer is 1, second layer can be 2 and 3. So there will be two pairs. Okay, I'll just go to my writing screen. Just a second. So yeah, what was this question name? Cake, cake making. We'll just keep it as cake making. Okay, just a second. Okay, so cake making. First point, the given inputs are 2 comma 3. So here, what are the cases possible? When it's 2 for the first layer, it can give me two outputs, which is 1. Okay, first wait. So a value is 2. So in that case, the possible cases are 1 and 2. So here, when it's 1, the number of these things, the cakes which it can be matched with the and this 3 is having how much? 1, 2, 3. Since we have 1 here, it can only have 2 and 3. Since we have 2 here, it can have 1 and 3. So what is the total number of pairs? 1, 2, 3, 4. I hope it's very clear. It's a very simple question basically. So yeah, 1, 2, 1, 3, 2, 1, 2, 3. So what did we get here? 1, 2, 1, 3, 2, 1, 2, 3. So that's exactly what we got. So yeah, that's all. Now we'll see for the intuition and all. Very easy question. I'm not gonna explain these very deeply, but yeah, intuition. So sorry guys, there was a small disturbance. So yeah, intuition. What we need to do? We need to count all valid cake combinations. Count valid cake combination. Cake combos. So first point, first layer is 1 to A and second layer is 1 to B. Max is B. So yeah, total combination without restriction, how much we will have? It is A into B. Without restriction. Without. This is without restriction. Now we have a restriction here which says you have to not have both similar colors. You should not have similar colors in the both ones. So hello guys. So now if A into B is giving us without restrictions, what we'll do is simply subtract the minimum of A comma B, which is it can be A or B. When we this is basically a restriction here. Once we do this, that is the whole thing. We'll get the required answer. There's oh shit, sorry. There's the whole thing in this whole question. There's nothing. We'll go to the approach quickly. Approach. Yep. First, read integer. Read int A and B. Input, take input. Basically, count valid cakes. So how we will count it? Count cakes. Valid cakes. Chalo. How you are gonna count this? First, if condition, if A lesser than or equal to B. First layer has A choices. A first layer choices. A choices. First layer, for first layer. And then for each second layer there are B minus 1 choices, because you have to leave this one A here. So what is your final total? It is equal to, total is equal to A into B minus 1 in this case. Next, there is one more condition, which if B smaller than A. In this condition, second has B choices. So first choice is A minus 1. So total is equal to B into A minus 1. That's all as the whole code. And then we have to print result. Print result. That's all guys. And you all are very aware of this, the time complexity. I have written the pseudocode almost, only to like there's no loop, nothing. So yeah, it is basically O of 1. Space complexity, only A and B are used, so O of 1. Now I'll quickly write the pseudocode. Pseudocode for this: A comma B, map input, IP, int input. That's int input, int comma IP dot split, and then print A into B minus 1 if A smaller than or equal to B, else B into A minus 1. That's all guys. There's our pseudocode. I wrote the whole code itself. So I hope everyone are clear with this. I hope everyone are clear with this guys. Anyone in the chat, would you guys please respond if you are clear with it? We'll quickly jump to our second question, which is What is our second question? Okay, so I'll just submit this code. This is my code. I mean, yeah. So just submit it quickly. It will clear all the test cases, guys. No need to worry. Yep, it's done. Close this. Brick comparison. So yeah, we'll go to comparing bricks. Even though we are computer science engineers, we have to do civil works. Brick compare. Done. So here it is. Brick comparisons. So what does the question say here in this? Chef has n bricks with him, each numbered 1 to n, with the ith one being size of a of I. So he has how many n bricks with him, numbered 1 to n, with each ith one being size of ai. He'll first perform the following process. First he picks up brick number 1. Then he looks at the other bricks in order 2, 3 up to n, and if he finds a brick that is strictly larger than the brick in his hand, he drops it, and then he'll pick the he drops his current and picks up the heavier one, like the larger sized one. So yeah, your task is to find the number of brick which is finally with the chef at the end of the process. So what we have to do is we have to find which is basically the brick that is with the chef at the end of the process. For example, if a is equal to 2143, the process happens, he picks 1, then brick 2, then it is heavier. So yeah, chef, then he'll first pick brick number 1, but then chef picks up the brick numbered 1, then he'll look at the brick number 2, but it does not have a size larger than the current brick. So he'll look at brick number 3, which is larger than the current brick. So he'll drop this and he'll pick the brick number 3. Brick number 3 here is having the size 4. So yeah, it is. Then he'll go to brick number 4, but 3 is actually smaller than 4, so 4 is the heaviest one, like 4 is the largest one. So I'll have the final brick with chef. So what we can do here is input format. First line of input contains a integer t denoting test cases. Second layer is each test case consists of multiple lines of input. First line is n number of bricks. Second line is n integers a1, a2, an, which is the size of the bricks. Now output format. So we'll go to the output format, which is the brick which is in chef's hand finally. Constraints is t less than 100, n less than 100, a of I. The size is also less than 100 and greater than 1. All the three of them are. So now, okay, fine. So yeah, now what will happen? They have given that strictly increased. So if he will have a bricks order of what? 2, 1, 4, 3. Now brick 1 is heavier than brick 2. So he'll be having brick 1 itself. When he comes here also it is 1 itself. But when he comes here, what will happen? He'll pick brick number 3. And then when he comes here also it is brick number 3 only. So finally in his hand it will be brick number 3 only. And now we have one more case. We'll take 4 and 4. Not 44, 4 comma 4. So in this case he has brick number 1, and then when he comes here also he has brick number 1 only, because they are given when it is strictly increasing only he's gonna change. So in this case also the output is 1. 1 is the output in this case. So yeah, we'll go to intuition quickly. Intuition, which is He always starts with a chef starts always with first brick. Then he goes from left to right. Left to right, this direction. If strictly large, if strictly large, switch brick, not switch condition, it was switch the brick. Switch the brick. Next, else ignore, else continue with same, continue same brick. Done. Now basically he'll just have the largest brick. He holds largest brick. That's all is the whole, whatever the drama, whatever the question given, it's that's all. Now we'll go to the approach. Done. Quick. First line, T, test cases. Then we have what? For each test case, for each T, what we have to do? We have to read number of bricks and their size and size. Now what I'll do after this, once this is done, what I'll do is I'll take a variable, some x, y, z, m, and anything. I'll take it m, variable m. It will store the index of brick chef is currently holding. Current index. Okay. So it will start with 0. So brick 1. I hope everyone is clear with this. It was brick 1 he is holding. Now what I'll do is I'll simply traverse from I is equal to 1 to n minus 1. And if I find this condition, if a of I greater than a of m, I'll update it. I'll update m equal to I. Now final output is output equal to m plus 1, because m is having the index. M, remember guys, why we are doing this plus 1 is m is having the index, but bricks count starts from 1. So plus 1 is for bricks count. Bricks count. So I hope everyone is clear. Now done. So yeah, time complexity, generally it is O of n very easily. O of n, basically single for looping, but for given test cases in 100 we can reduce it to at most 10,000 operations in the worst case. O of 100 into 100 as per given, which will lead us to O of 10,000, mean 10,000 operations. But yeah, in general it's O of n. Space complexity is gonna be okay, I'm sorry, there's a small mistake I did. The time complexity of O of n is for finding largest brick. But it will also depend on the number of test cases, so it is gonna be O of t into n. This is a final time complexity, that's all, nothing much. Now we have our space complexity, which is O of n for storing in array A, in A array A, and then O of 1 a few extras. Now after this is done, what we'll do is we'll simply write it as O of n space complexity equal to O of n. Done. So yeah, that's all guys. Quickly we'll move to the this one, what do you say, code. I'll just directly submit it. So yeah, as I told, our t is the input, then we have range t will take the input. First four lines are for inputs, then m we are taking the counting the index. M is equal to 0 for I in range 1 comma n. A of I is if A of I is greater than A of m, then m is equal to I. If not, ignore it. That's all, just ignore. And finally we'll print m plus 1. That's what I actually explained the whole pseudocode in approach itself. So yeah, submit it and drop it. Quick bhai. Codechef, why are you so slow today, man? Done. Quick. Fence coloring. So yeah, I hope everyone is clear with that question. I hope everyone is clear with that question, guys. So quickly moving on to fence coloring. Fence coloring. You have n fences and you want to color them. You have n total types of colors numbered 1 comma 2 up to n. Currently n fences are colored with type 1 color. At the end you want ith fence to have a color AI for every I which is in the range of 1 and n, including both. You can choose to do one of the following at each minute. Color all n fences at the same type X color, which you can choose from X's in the range 1 or of 1 and n, including 1 and n both. Or color a specific fence I with type color X, again it is in the same range. Both of the above operations takes only 1 minute to perform. What is the minimum number of minutes needed to color the entire fence as desired? So yeah, if you just consider it as you're painting your home's fence, and this is the condition, you can color all the fences at the same time. Okay, we'll go for a writing screen. Fence coloring, third question. Fence color, fence coloring. Okay, I'll use a different color. Done. I'll use red. Understand it easily. And I'll use a different color. I'll use brown, and then I'll use one more different color. Random color, ocean. ठीक है. This is one random, and this is one more random. Now I'll switch back to my white. Now there are two ways you can color them. One, what is the first way you can color them? We'll consider the first one as global coloring. Okay, so you can color everything at once with white. So I'll just color it down. For this, you can color it this way, everything with white at once. And then what else you can do, you can also color individually. For example, consider I want to color this brown first, only this, or only this, like this also you can, only these two, like this also you can color, not these two, only one fence only at a time. For this or this, it will take only 1 minute, 1 minute per operation, per paint. So it's a very fast technique. Our goal is to find our minimum time. What is the minimum time? We have to find the fastest painter, basically, whosoever can paint the fastest, guys. So yeah, that's all it is. So how can we solve? Anyone in the chat, will you guys get? So hello guys, sorry again. So yeah, What is our intuition here? As I said, we'll take it as two things. One is, initially we'll keep fence color as color 1. Color 1. Okay. So initial configuration is a of 1 to a of n. And two types of moves are there. Two types. As I said, we'll keep first one as global coloring, and this is all fences will be colored at once, same color. All fence same color in 1 minute. Now next we'll keep it as single color, single fence color. Here what we'll do, one fence to, okay, this is all fence to one color in 1 minute. This is one fence to one color in 1 minute. In 1 minute. So this is what is given, and our goal is to find, as I said, fastest painter. That is minimum time. Both are same. Fastest painter, minimum time, whatever you want. However you can understand, keep it that way. Now how we'll do, we'll go to our approach quickly. All this were easy questions, so I'm doing it fastly. Approach. So yeah, first one, first step, what we'll do, count occurrences of each color in final state. Final desired state will take. Done. And then in our second step, what we'll do, case 1 will take. Case 1, which is global color. No global recolor. This is no global recolor. So what we'll do, we'll just take just fix all the fences that are not color 1, and it takes n minus f of 1 minutes. Fix fences not color 1, that are not color 1. Not color 1 is what? Our initial color. You guys should remember this. Color 1 is our, where is this? Okay, this is our initial. Remember this. Now going on, not color 1, fix them. Now we'll go to our next step. Case 3, case 2, step 3, case 2, global color. One global recolor to some color C. One global recolor. One global recolor, what we'll do here is, first what we'll do, here we'll make 3 steps. Step 1, what we'll do is recolor all fences to C, color C. Okay, it will take f of 1, it will take 1 minute basically. It will take 1 minute. 1 minute. Then step 2, fix fences not C, that are not C, that are not C in final and in the final stage. So how much this will take? The time this will take is n minus f of C minutes. Earlier how much did it take for us? How much did this take? N minus f of 1 minutes. F of 1. 1 is our color 1 basically. Now what is our total here? In step 3, 1 plus n minus f of c minutes. These are total. Now in our fourth step, final step, fourth and the final step, what we'll do is minimum of case 1 and case 2, case 1 and case 2 for all c, like it's basic for all c. So yeah, that's all. These are approach. I'll give you guys the code for this in my submission. So I'll just quickly write the pseudo code. Input and all I won't write. Understand that. Pseudo code. Yeah. Bhai, 4 lines of input, bhai. Whatever it is, you guys take it. Take input, test cases, all those nonsense stuff, whatever they ask for. Then run a loop for the test cases. And then make a frequency array for colors, which is f is equal to 0 into n plus 1. This is frequency array for colors. Done. Now run another loop for a in array. What you will do, if 1 is greater than or equal to a, greater than or equal to n, sorry, if 1 is lesser than or equal to a, if a is lesser than or equal to n, in this case what you will do is f of a plus equal to increment f of a by 1. Then you take one more variable k is equal to n minus f of 1, which is case 1 basically. Now for case 2 you will go one more, then one more for loop for c in range. This is color. Second loop are same, 1 comma n plus 1. What we'll do here, m is equal to, we'll take one more variable, m is equal to minimum of m comma n minus f of c. F of c is we already discussed. And our final answer, then we'll print answer, which is minimum of k and 1 plus m. This 1 plus m is because we'll be adding this 1 here. Where is this? Yeah, this 1, and this is considered as m. So that's all is our answer. Finally print the answer. Done. That's all is our code. Time complexity now, very easy one, everyone will say, I guess. So O of n for looping over colors, and that is all is basically the overall. O of n is our total time complexity, and our space complexity is equal to one frequency array we have taken, which is O of n for the frequency array. That is our final. Rest all are single letter variables, so we'll be ignoring it and big of n. So space complexity equals O of n. That is done. I'll just go to the code for a second so that, yeah, here is the code inputs. This is all input. Then this is our first for the color 1, and this is our case 1. Case 1 is here, and here is our case 2, and then final output. I'll just submit it quickly and I'll move to the next one. I hope everyone are clear with it. I hope everyone are clear with this, guys. Okay, someone has a doubt. Ghost Ranger, how to boost CGPA? So you're asking a wrong person. Someone with 9.5 should not ask others those questions. That's all I would like to say. Now, moving on to our next question, which is GridMax. But Ghost Ranger, yeah, if you wanna ask how to increase your problem solving skills, I can say you that, but not about CGPA. So yeah. Now, grid max. Last week also there was one min max, I think, I'm not sure. Well, so yeah, we are given with an integer n. Construct an n cross n grid where n rows and n column filled with n square integers. A I j represent the first element in ith row and jth column. Define Vj. I'm sorry guys. Define Vj be the set of all elements a of xy such that exactly one of x equal to I and y of j equal to j holds. In other words, Vij is the set of all elements in the same row or column excluding I comma j itself. So yeah, grid must satisfy the following condition, which is a of ij must be in the range 0 to n minus n square, including both of 0 and n square. And aij is max of Vij. Okay, max of s is defined as the smallest non-negative integer not present in s. Max of an empty set is defined to be 0. Last week we discussed about max. So if anyone has a doubt what max is, please go to the last live stream and check out. So yeah, we'll quickly move on. Input format is single integer t denoting the number of test cases and only one line containing the single integer n. Now output format, for each test case output n lines with n integers. The jth integer of the on the ith line should be of ij. You are allowed to print any valid grid. So you just have to print any valid grid, and constraints they are given t less than 30 and n less than 30, greater both are greater than or equal to 1, and less than and equal to 30. So yeah, that's all guys. Now quickly moving on. Now we'll move on to our writing page. Max grid, huh? What was the name of the question? Grid max. Okay, not max grid. Fourth question, max grid. Or grid max again, did I write it reverse? Okay, whatever. Grid max, max grid, both are same. So yeah. So firstly, our intuition. Our intuition is we have to create a grid. We have to construct n cross n grid. Construct n cross n grid such that a of ij equal to max of v of I comma j, and there is a condition for this. V of I comma j is all numbers in same row or column excluding ij. That's all as this thing. Here we have some key observations to note. Key observations, I'll just write it as very important points. First one, definition of max. I'll repeat it quickly again so that if anyone wants detail, yeah, go to the previous live stream and watch it. If not, subscribe to the channel and come back again, or put it in the comments so I can explain you guys. So max is a set of small max of a set is equal to max of a set it equal to smallest non-negative integer not in set set. Done. That's all, guys. So basically, for an example, e.g., what can I give? I'll give a set 0, 2, 3, 5, and max of this is, and this let it be x is equal to max of, or I'll take r, max of r is equal to 1. This is what is max. Now quickly moving on, when we observe, there one more point in key observation. If we observe, we fill the grids from 0 to n minus 1 in cyclic pattern. So where we can make sure, if we fill it this way, what we can make sure, 0 to n minus 1, we can make sure that every row and column will have numbers from 0 to n minus 1 except one number exactly, which is max. So we can ensure every number is there except one, only one number, which is the mix. Done. Quick. Now for this, what we'll do is, third important observation point, I plus j modulo n. Just a second, guys. So yeah, mod n, when we do this way, what will gonna get us? Here three conditions. Each row is a rotation of previous. Each row a rotation of previous. And second one, what we'll get? Each column contains 0 to n minus 1 without repeat. Done. Now for each cell, I comma j, removing this one element ensures the smallest element is put. This element ensures exactly the number we put is the smallest. Exact number we put is the minimum. The smallest. I'll write it as min. So yeah, we'll go to the approach quickly, guys. I guess it's already 11:11. So approach. So yeah, first one, run a loop over the rows I, which is from 0 to n minus 1. Second point, for each row, fill a of I j as I plus j modulo n. So this is what I explained here. I plus j modulo n will be filled for every I comma j, like every a of ij, and then this will automatically gives us the mix. or what can I write? Satisfy mix. Satisfy mix. So yeah, that's all. Now what we have to do finally, third step, print the output, which is print grid. So done. Now time complexity, guys, blindly we can answer a grid question. What is the time complexity? Simply O of n square. Just directly write 99% of the times if it's a grid it will be O of n square. And the space complexity, a single array, one row we are storing, so it is gonna be O of n. That's all. Now quickly I'll write the pseudocode. Okay, take the input, take input, all those 4 lines input nonsense. Then for I, run a loop for I in range n. So what you will do here, you will fill it with rho is equal to the modulo 1 which we did, I plus j modulo n. Now here what you will do, you will take rho is equal to I plus j modulo n for j in range of the 4 columns in range of n. And then what you will do is you will print this thing with a space so that it will look good. And you know, whichever language you are doing, print it with a space. In Python, join, map, str comma row, whatever, like whichever language you are using, print the answer with space. Print answer with space. That's all is this. Very short, simple code. I honestly didn't even know why it was like the fourth or the fifth question. It was a very easy question, honestly. Very, very easy question. That's all. Quickly submitting the code. Done. Okay, bhai. Submit. I hope it works. Yeah, it does work. I did give the contest today. So yeah, it works. Done. Now, quickly moving on to the next one. Sorry guys. Which is perfect ranges. One of the little bit difficult questions. So yeah, one of the little bit of a tricky question today. Not a hard question, but a tricky one. Yeah. Perfect ranges. What does the question say? A pair of array A and B, both of length n, called perfect if it's possible to form array C of length n satisfying the following condition, which is C of I equal to A of I or C of I equal to B of I for each 1 smaller than or equal to I and I smaller than or equal to n. C of I should be smaller than C of I plus 1 for each one small, again the same, I in the range of 1 to n including both. You are given with two arrays A and B of length n. It is guaranteed that each element from 1 to 2 into n either occurs once in A or occurs in B. How many pairs of L and R exist such that 1 is smaller than or equal to L, which is smaller than or equal to R, which is smaller than or equal to n. The pair of arrays A of L comma R and B of L comma R are perfect. Here A of L comma R represent the subrange A of L comma A of L plus 1 comma A of L plus 2 comma up to A of R of the array A. Now our input format. First line t, and then multiple lines of input again for every test case, which is n size of arrays, n the size of arrays, and then the second line, and the second line which is n integers a1 a2 up to an, and the third line n integers b1 b2 up to bn, and our output format new line of number of L and R such that it corresponds in the subrange A and B. We have to just find if A and B are perfect. Constraints are T is smaller than 10 per, like the test cases are between 1 and 10 per 4 including both, and then N is smaller than 2 into 10 per 5 or equal to, I mean it's in the range 2 and 2 into 10 per 5 including both. A of I and B of I both are in the range of 1 and 2 into n including both. A of I not equal to A of j, B of I not equal to B of j for any 1 smaller than or equal to I smaller than j smaller than or equal to n. So, and then A of I not equal to B of j for any 1 smaller than or equal to I comma j smaller than or equal to n. I comma j lie in the range 1 to n including both. Sum of n over all test cases would not exceed 2 into 10 power 5. That is all. So yeah, and given the sample outputs, all those stuff. So we'll directly jump into the approach, intuition, whatever it is. Just name of the question, perfect ranges. Fifth question of the day. Perfect ranges. Quick. Come on. No. Don't know. I used a very lengthy method. If anyone can come up with a better approach, you guys can come up. So I used a very long code. I mean, after the contest, when I was thinking, did I actually write this much of a big code for this? And honestly, I could not come up with any better approaches myself. If any of you guys are able to come up, it's a really good thing. Please try and get it, guys. So yeah, now perfect ranges. We have read the question, everything is done. We'll quickly jump into our intuition. Done. A B arrays, A and B arrays of length n, unique elements from 1 to 2n, such that each element exactly occurs in A or B, never in both. Never in both. I hope you guys are clear with that. First step. Now we need to count what? We need to count number of subranges L comma R for which C of I is either from A of I or P of I, so that C of L smaller than or equal to C of L plus 1, smaller than or equal to, it goes on, and the largest one will be C of R. Now there is a small tricky part here, which is we have to consider, just I'll write shortly all this theory. We have to consider both possibilities. For each position, so yeah, that's all. Picking A or B, picking from A, or B, pick from A or B. So yeah, that's what. Basically what we are doing is we are trying to mix both of them or stitch, like we'll just come take it like this. We are okay, thus let this be one and let this be another one, this thing A B, consider it. We are gonna stitch both of them, and we are trying to make, what are we trying to make? We are trying to make an sequence increasing sequence for two possible options at each step. For two possible options at each step. Done. Now what we'll do is we'll bring in the one of the very important approach, which is divide and conquer. We'll just bring in and dump it here for subranges L comma R to make it fit into the approach, instead of simply checking like a idiotic people, like going on through all the cases. It's better to apply divide and conquer. Now quickly going to the approach. Okay, first, most of you are aware how merge sort works. We'll try to make a solution which is similar to merge sort, like divide. Merge sort we all know uses divide and conquer. We'll try to give a solution similar to merge sort, like divide and conquer. Similar to, not exactly ML. Similar to merge sort, like divide and conquer. First one, we'll divide it. Divide, which is split array to two halves at midpoint, mid midpoint mid. So yeah, and after this, what? Recursively compute results for left half and right half. Now next is divide is over. Now conquer. How will conquer it? First step, merge two halves, counting by Merge two halves by counting subranges that start in left and end in right half. Left half, end in right half. Subranges start, end in right half. Basic guys, merge sort, nothing of a rocket science here. So yeah, clear. Now we'll do a boundary check. Boundary between halves. Boundary between halves. What we'll do for this boundary, two possible scenarios for each step is there, which is L0 or R0. Choose small value. Choosing smaller value from our big A of I comma B of I. Now, and the other one is L1 comma R1. Choosing smaller is done, so now larger value from the same A of I comma B of I. That's all. Done. Now along with it, we'll track the state. State tracking. If anyone did with a different approach, quickly put it in the chat, guys. State tracking is what? Will extend the midpoint. While extending midpoint outwards, will maintain OK arrays to track valid increasing sequence. That was possible when extending from left to right. This is from extending from left to right. Now, second one, maintain min and max arrays to store smallest and largest possible values, possible chosen values for each prefix or suffix. Done. Now, once this is done, now we'll do a process which is called merge counting. Again, whatever we do in the merge sort, similar to that. Compute all possible starting values, start vals from right half, and all possible end vals. From where should we get the end vals? From where, guys? From the left half. Done. Now what we'll do, we'll use bisect right, binary search or bisect right. I'll write binary search, it's better. Oh, from our left half. Okay, next pointers for each left value, use binary search. On sorted right vals, this is to count how many matches produced, how many match in strictly increasing order, strict increasing order. Done. Final step, guys. You've done everything up to now. Fifth step and the final step, combine everything. Combine and give the output. Now combining, what we have to do, add results from left half, right half, and merged cross boundary subranges. Now what is the time complexity? I'll go to the time complexity for this. Time complexity a bit complex. Each step splits in the half. So now time complexity of n is equal to 2 into time complexity of n by 2 plus, sorry, t of n is equal to 2 into t of n by 2 plus O of n log n. Guys, 5 marks question for most of the colleges. Most of the colleges. So quickly, any one of you in the chat, simplify and tell this. O of what? Okay, anyone in the chat? Okay, I can see one chat. We'll just tell you guys. Yeah, you're correct. O of n log of log n, which can also be written as log square n, however you guys are comfortable. Just write it somewhere, somehow. Now this is done. Space complexity. Temporary arrays O of n, temp arrays, recursion depth, O of log n. What is the final space complexity? Anyone in the chat, what is the final space complexity? Now, this is equal to O of n plus O of log n, which is finally equal to O of n. So your space complexity is O of n. This is a very long code honestly, so I'm not gonna explain the whole code here. Instead, I'll give the link of this so that you guys can see. Yeah, I'll give you guys the link in the description for the submission. You guys can read it as mentioned in the first line, read and understand, but yeah, don't copy paste the whole whole code. That's all guys. Now I'll submit. It will definitely work. I have given it in the contest itself. Yeah, so it should work. I mean, yeah, we'll see if it works or not. Done. हाँ भाई चल गया. It works perfectly good. And so the final question of today. I mean, yeah, the final question. XOR game by. Again, one more like it was a bit difficult. Honestly, this was a difficult question. I'm not lying. This was a bit difficult, but still solvable since many people solved. Quickly going on. What is the name of the question? XOR game. Sixth question. XOR game. That was the last question I solved today personally. I did solve the final question, which was what was the next question we had? Some recursive lines, or what was it? Yeah, I'm not sure. Just give me a second. Let me check what was the last question which we had today. What was the question we had today? Replace with coefficients. Replace with coefficients. That question I could not complete it within the given contest time, but I did solve it after the contest was done. But yeah, no need of solving that question. Quickly going on to this final question of the day. So our final question of the day, XOR game. We'll go back to our question. Where is it? XOR game. Alice and Bob. Alice and Bob are playing a game which involves an array of length and containing non-negative integers. The following sequence of events occur exactly once. Alice chooses two not necessarily distinct indices I and j. Then Alice sets a of I equal to a of I XOR a of j, where the symbol denotes bitwise XOR operator, and then a of I as a of I XOR a of j. But Bob chooses two not necessarily distinct indices I and j. Then he sets a of I XOR same, exactly the same one. The score of both is calculated as a of 1 XOR a of 2 XOR a of 3 XOR up to a of XOR a of n. So Alice wants to maximize the score while Bob wants to minimize the score. Assuming both players use optimal strategies, determine the final score. Now, both of them actually wanna win. So yeah, since that is the case, what we are gonna do is we'll take this one. What we are gonna take our. Okay, I guess we have to take a modulus answer, or was it for the okay, sorry, no. We'll go through the input. Both of them wants to win. Alice wins by maximizing, Bob wins by minimizing. We'll try to understand it this way. So both of them will try to win. When it's equal forces, probably we won't get a clear one-sided way. So we'll check input format T denoting test cases. Then we have for each test case n the size, and then a of 1 to a of n. Done. Output format optimal score, whatever is the score. Now a constraints 10 power 5. Okay, we have a of I which is smaller, which can be in the range 0 to 10 power 30. Remember this. And some won't exceed 2 into 10 power 5. Done. Rest all are from like the normal range. Test cases is below 10,000 and greater than 1, which is 10 power 4, between 1 and 10 power 4 including both, and n is in the range 2 to 2 into 10 power 5 including both. Now quickly going on. Now what we'll do is we'll take an example to understand this question, because this was difficult as I said. We'll take one example. Alice will choose I equal to 1, j equal to 1. So now what we'll do, a1 is equal to a1 XOR a2, which is gonna give me 0. Now what will my a become? A becomes 0 comma 1. Now our boy, this is for Alice. Now what our Bob the builder does is, this guy will take I is equal to 2 and j is equal to 2. So this will change a in a for 0 comma 0, and the score will be, the final score will be, our final score will be 0 this way. Now if we take one more example, we'll take one more example. Alice will choose I equal to 1, j equal to 2, and now this will change a to, this will change a to 3 comma 2. A is equal to 3 comma 2. Now Bob will choose, what will Bob choose? I is equal to 2, j is equal to 1, and so what will this do? This will change it to a is equal to 3 comma 1, which has a score of, score is equal to 2. So yeah, this is what is done here. I hope everyone are clear with it. Now we'll jump to our intuition approach, whatever we use to solve this. Quickly moving on. I'll go quick again. Not a hard, like tricky question again, a bit hard. Intuition. Come on guys. 2 players. Alice and Bob. Alice will try to maximize XOR, max, final XOR, max. Okay. Alice wants to max final XOR. Bob minimize final XOR. So yeah, this is what. And how does the game flow goes here? Game flow. Alice changes one element a of I to a of I XOR of a of j. Now Bob will change, this is Alice, I'll write Alice. Now Bob the builder's turn. Now this guy builds. What he'll build? He'll change A of I into A of I XOR of A of J to minimize it. Now the final score is XOR of elements. Final is XOR of, just a second guys. So yeah, final score is XOR of all elements after both moves. Both, sorry guys, just a minute, I wrote mistake, I told properly. XOR of all elements after both moves. Done. That's all. Now quickly going on to our approach. Now what we'll use, you might be aware of trie data structure, which is a bitwise tree. Basically we'll use a binary tree, binary trie, which is a bitwise trie to store all elements for fast minimum XOR query. Okay, all elements stored for fast minimum XOR query. Done. Now what next step, we'll pre-compute a lot of stuff. To handle cases. Which cases? Pre-computation where Bob has limited options. Where Bob has limited options, elements. Again, Bob's freedom. Alice has a freedom. Bob is having restrictions. So we'll go for steps. How we'll do? I'll just write it as a different one. First, what we'll do? Initial XOR of array. Initial XOR of all elements of array, basically of array. Compute this, and after this, what we'll do? We'll compute x is equal to s XOR of u of I for each element and this, what is this? This is total. Oh, this is the total XOR. This is the total XOR Alice can force. Alice can force after her move. This is before Bob plays. That is before Bob plays. Now it's turn off our. Now what we'll do in our third step, we'll insert all a of I into a bitwise try. And next step, for each Alice move, we'll go for each Alice move what is possible. There will be three cases here. For each possible Alice move, we'll find three things. What is it? First one, minimum v of I. This is minimum of possible XOR that Bob can force. That Bob can force. This happens by picking a of k some a of k picked optimally. Pick optimal. That's clear, I hope. Now what happens? Second thing we have to do is index idx m of I. What is this? This is index achieves index of element that achieves min v of I. There is the index of the first A. Now the final one here, C min 2 v of I. What is this? Second minimum possible XOR for Bob. Second min XOR for Bob. If he can't use same element as min v of I. Oh, hey, sorry guys. Now that's all is here. Once this is done, we'll move on to our next step, fifth step. Yeah, I guess fifth step, which is track global best and second best. Minimum values, min vals, to handle exclusions. Done. And in our sixth step, final step, what we'll do? Final, no need to write all those, too much theory. Finally, what we'll do is check possibilities of Alice choice and Bob's optimal counter. Optimal counter attack or counter basically. And then what we'll do, we'll select max final score that Alice can guarantee. Done. That is all we are doing here. Now we'll go to our time complexity first before going to the code. Building try. Who are all not aware of this, it is gonna take O of n into bits. Now querying, we'll take it as querying min XOR, which is again on the same tree, so it is O of n into bits. So overall it's gonna take O of n into bits. Here bits is 30, but yeah, let it be. Time complexity equal to O of n into bits. Now moving on to our space complexity. Again, space for building try storage. Try storage. What will it take? Those who don't know, O of n into bits. Those who know, really good guys, well and good. So yeah, and extra array, elements, and all those array and variables. Okay, fine. Extra arrays, it's gonna take O of n. Now what is our final space complexity? What is our final space complexity, guys? Which is bigger? O of n into bits plus O of n. Space complexity is equal to O of n into bits. Done. So that is all for this question. Okay, I have a question. Why try? So I clearly told why try is used, guys. Try is used because we need to quickly find the element in the array that will give us the minimum possible XOR value. Okay, DSA, is it clear? If you are still watching the stream, quickly reply DSA. I said why try was used. If we go for brute force, it is gonna take us a time complexity of, now for calculating what? Fast min XOR queries, brute force is gonna take you O of n square, which will pakka give you a TLE in any CP site. So to reduce this, what you will do, you will take a try. What will this try do? This try will do the exact same thing at O of n into bits. Now here the bits are 30. So imagine you brought it from n square to n into 30. So you have lowered it by a lot. Now this is the main usage of this thing. And also one more advantage of using try is it will allow you to like dynamically remove or reinsert the elements, which is like for the elements which Bob can't pick, the elements that Bob can't pick, right? those cases also can be handled here easily. That's the reason. I hope it is clear, it's clear. So that's all for today's live stream. Thanks everyone whosoever joined. We'll meet again maybe next Saturday for DSA bi-weekly. I hope. That's all. So thank you guys for joining the live stream. It was delayed, even then you guys joined. I'm really thankful for you guys whosoever joined. And until we meet the next time, thank you guys. Please like, share, subscribe to my YouTube channel. Hope you guys will keep practicing, and even I keep practicing and get better. So yeah, that's all for today's live stream. Hope everyone will be well and good. We'll meet in the next live stream. Thank you guys again. Please like, share and subscribe to my YouTube channel so that many people can make use of it. So thanks guys. Thank you guys for joining. Done. I'm gonna end my live stream finally.